So if I go to a smartphone plan,
Oh, dude, yeah. Get a smartphone.
if I go to a smartphone
We have a group
plan,
chat.
does anybody have like a really old smartphone that feels kind of good?
I do. I have
That I can just have?
Yeah, I'll sell it to you for $10.
Cracked though.
Hey, I have It's cracked and it's like a
Mine still
Galaxy
Blackbird.
Zero.
I have
You
an
would just
iPhone
need
5
a
that's now.
new, you
My
would need a
almost
new
knows
screen
how
for
to
like
call
90 bucks, like 80 bucks.
Kramer, I haven't uncracked
For
that.
how?
My iPod still has my fucking birth
Oh, I
high
fixed mine for free.
Is that the one that doesn't hold charge?
From the fries. No, I fixed it
Calculator.
myself.
Where'd you get the screen?
Bought it off Amazon for
Why?
$5.
My old Motorola still has fingerprint, so
Do you have a calculator like this?
you could use that.
Have
You
one
could
of
use
these?
that.
I have like a really
You should.
Because I have an iPhone 5S that's sitting on my
You can text people on it.
The broken one? Yeah.
See, that's why during tests,
Over radio wave.
My
during
parents
tests,
are
we can
giving
text
my
each other and just check our answers with each other.
It's just visual.
Yeah, because
They're
here
gonna
the
waste
bus.
that one.
Like,
Alright, here we go.
the answers with like
Yeah, we Google on this.
Hey, Cole.
So we talked yesterday about impulse. Impulse depends on two things. What are those two things?
Force and time.
Force and time. Put away your calculator.
Well, I'll leave it for this.
Okay?
I'll set it down.
What did impulse depend on? Sorry?
Force and time.
No.
Yes.
For momentum and force and time and mass times velocity.
Mass times velocity. The change in momentum can be described as a force times the time. Okay, but momentum is based upon the mass and the velocity. We talked about yesterday how if you have two objects and they have different masses, they could still have the same momentum if the smaller or the lighter object was going faster, fast enough to make their momentums equal. Okay, so essentially, when something goes and gains momentum, it's more difficult for that object to stop. Okay? Right off the bat, if an object is more massive, it already is more difficult to stop. Just because of the fact that it has more inertia.
So then it's a direct relationship.
Yeah, I would say so. As your inertia goes up, so will your momentum, assuming your velocity is not zero. Okay? Now, we talked yesterday about the force, or the impulse equation, which was your force times your change in time. Really equals your change in momentum, but most of the time you're never going to be solving for change in momentum. So it would be your MVF minus your MVI. Okay? Now we can use this particular equation to figure out how long it would take an object to stop, or how much force it would take for an object to stop in a certain time frame. Okay? This particular equation is used a lot of times when dealing with when people try to come up with safety equipment and stuff. Okay, so what, for example, why do you think people use a net? Why do you think firefighters use a net versus just letting them jump straight to the ground? Because they'll die. Alright, one person raised their hand, I can't. Bryce, go ahead.
Distributes the force over a longer period of time.
Okay, so what does that end up doing then? If it
Giving the force is reduced.
the force is reduced. Okay, so if you take and you stop something over a longer period of time, what you end up doing is reducing the force so that you can just do a little bit of force over a longer period of time, thus changing its momentum. And less what?
It's the unit
The unit of love.
Oh my gosh.
How do I go home and I have to go through psychic therapy?
Says the one with the wife.
Oh, it means the
No, it's
love.
supposed to go too long.
Alright.
Very expensive.
Loves are being roasted.
I didn't know that. I think
I'll put a curse on you. Then we get married.
Oh,
Curse. Curse on you. I don't curse on you.
I don't think it's.
Nice!
Get
Wait,
Two negatives make a positive, right?
Okay.
Wait, one of you has to get now.
So stopping times and distance. Okay, you can figure out how long it would take an object to stop, assuming you're maintaining a constant force. Like for example, we can have a car traveling at a certain speed, and we can figure out if we are going to stop before the stop sign or not with this equation, depending upon when we push our brakes. Okay, we do have to make the assumption that when you apply the brakes, it's applying a constant force all the way through the stopping duration, okay, or the collision if you want to call it. Technically the collision is between your brakes and your wheels, okay? Now, let's say that my change in momentum is 2,000 kilograms times meter per second. Okay, that's how much momentum I would have to change for an object to stop. I'm just making a random number up. Use it as an example. Okay? Force times change in time. Okay, say two different situations. Let's say this was the amount of momentum you would have to change if Avery jumped out of a building and came to a stop on the ground. Okay?
Very real.
Alright?
Do a flip.
So, let's say that this is going to be hitting the ground.
I was hiding.
Which one is stripe?
Okay. Let's say that when Avery hit the ground,
He died.
it stopped his momentum in about 0.1 seconds.
So you were like,
Solve for F, please, everybody.
why?
Solve for F. Pretty easy to solve for F.
2,000.
Okay? So the force that is pushed upward on poor Avery, it's actually probably stops him a lot quicker than 0.1 seconds. Okay? The force pushing upward on Avery is 2,000 newtons, aka crushing balls.
That is not good.
Another ball that goes into the ground.
True. Okay? Then let's say Avery's two friends, okay, are holding a net. I'm one of his friends. The other one is actually an actor. Okay?
What?
His mother. And then,
Oh,
Bad.
so me and
The only
Beth,
two friends I have are you and my mother.
yep, me and Beth are holding this net. Okay? And
Beth is witnessing my death.
the time it took for him to hit the net to when he came to a stop after the net stretched was, let's say, about 1.5 seconds. Not a huge difference in a collision time, if you think about it. Okay, but it has a significant difference on the amount of force that would need it to be applied here. You guys can't do this one in your head, so
1,003. No, 133.
133 newtons. That's a lot less. What do we say? This one was 2,000 newtons,
I mean, that's the same.
and this was 133 newtons. Now that's a pretty big difference in force just by changing the time 1.4 seconds. Big deal. Okay, so you can see how what happens is if you can take the force and apply it over a longer time period, it significantly reduces the force that you would need to stop an object. Okay, and can save a man's life.
Whoa. Save a bush. Get back to you.
All right. So
Come on.
let's see. Anything else I need to add to
Cycle of
this?
bush.
Okay, so let's say two identical trucks. Okay. literally identical. Same brake pads, same everything. Okay? One truck has a load of bricks in it.
If you had a truck, what would you put in?
Okay? Which one's gonna stop quicker?
The not
The non-loaded truck.
brick boy.
No, that's why it takes.
Less mass, you have to slow
big
down.
trucks to take off.
Force needs to be
Like the
applied.
big
Yep.
semis do,
But
it
they always
takes
say-
so long.
And it also takes long for them to slow down too.
Yeah.
Okay? It's because they're just more
They're
massive.
always saying that.
Why? Who keeps doing that? Answer yourself, Cole.
Guys blow bricks in their truck.
That was not
Slow down
me.
real
You walked by it and tilted it.
Real fast.
I always plug it in.
Real fast. You ready?
Okay, let's do a problem. This is a good example.
Impulse there.
See the squishy boy.
It's like the egg drop project.
Oh.
I remember.
No, that was bad.
That was so fun.
I got
tried
so
to make
lucky.
it better and I made it much
I
better.
got
I got on the roof so
I got
many
so
times.
lucky.
Do you remember the car project?
Yeah, the car was
Yes.
cool, bro.
That was like amazing.
Oh, that was so cool.
That was pretty good too.
I wasn't in your eye.
No, I said wrong.
I jerked out though, he just made it.
Hey. Okay, so why is the egg breaking when it's dropped on a dish versus on a pillow?
Because the pillow is
Has nothing to do with squishy. The time of collision, or the time that it would take the egg to stop, is much greater on the pillow, and it's pretty much instantaneous when you drop it on some solid object. Okay? So what happens is, there actually is less force applied on the egg. Not enough force to what? The egg.
Break it, crack it, shatter it.
Paper.
Break
No.
it.
Papers. No. Have some eggs.
Chickens.
You put it on the sandwich.
Anchovies jam.
It makes me mad that you know the whole thing.
Such a upper class.
No.
Not sure this does it.
Where's Halloween?
Like, I
Where's
would-
Halloween?
This no love.
Why don't you guys comment to this?
This
November
Labor Day.
1st.
Okay.
Every holiday.
What's going on back there, you two?
Talking about necromancers.
Dungeons and
That's my
Dragons.
Favorite class to
As
run.
if an necromancer were to fall building, would he,
Actually, he wouldn't fall because he's not capable.
Well,
What are we talking about?
the bones would come apart.
So then you
Yeah, but they are stolen.
What dog do?
Like 11
Alright, let's do this problem. This is all we got for today, and we're done.
Yes.
Okay? Alright, Bryce, give me a variable.
Mass is 2,240 kilograms.
Wrong.
Isaiah, give me another variable.
20 meters per second to 5 meters per second.
That's not 20 meters a second.
VI is 40,
Can-
is 5.
VI is not 20. What?
Can the object itself decrease the time? Like if you drop Jello, it would like decrease its own time.
Yeah, a little bit, yeah.
So if I got really squishy,
VI is not 20 meters per
How is
second.
the initial velocity not 20? It slows down from 25.
From this to this.
How is
It's negative.
Thank you.
Got him.
Which makes no difference. Wait, time out. Didn't you say like 3 chapters ago it's better to just put direction than
Yeah.
than
Yeah.
negative?
Yeah.
Revolt!
Burn him.
What's the difference?
It doesn't work if you do addition subtraction. Because if you do addition subtraction, positives and negatives are very important. If you do multiplication, they're not, because all it does is change the sign. But when you do it,
So it makes no difference.
Would they both
This
be
equation's not
negative or just
squared.
20?
We're both
Yeah.
wrong.
No, it's not.
Oh, it's not. Oh no. Okay, I was looking at a different equation.
Everyone
I was like,
is wrong.
I was like, wait a second.
Alright?
Light's alive.
So, don't say that.
It's also negative 5.
Why do you say that?
You're hurting his feelings.
Can you explain?
He's a feeling. Like what?
What negative?
Yeah. That's,
Steven, I'm asking.
Oh.
What kind of sense?
Weast.
wow, that's so much better.
Steven, I'm asking.
Isaiah, are you bored?
I'm so bored.
Alright, Isaiah, could you give me a variable then, since you...
I did. I gave you the. Okay,
You
VF.
gave me 25, what the heck is that?
I said 22.5.
It's like you're in a variable. What variable is that?
It's VI and VF.
Okay, what's VF?
5.
Negative
5. Okay, 5 meters west. Meters per second west.
Oh, don't do that.
Okay. Cheyenne, another variable.
Force is 8410 newtons. That's not enough.
Otherwise, not.
Time? We want to know how far does the car travel during the deceleration. What variable is that?
We have to pull out the old display. Oh my god.
And we also don't know another important variable.
Change of time. So we got to solve for change of time.
Why do you think it's changing x instead of
Because we're dealing with, these are vector quantities, so I'm going to use the vector quantity version of
Wait, is this 2D? Like motion?
Yeah, one of them. So we can figure out how long it takes to stop. Guys, once we figure out how long it takes to stop, we can figure out how much it would travel under that time period. Alright. So we want to solve for change in time. What?
There should be a song for every holiday that just says the holiday name.
same song over again.
This is Labor Day.
This.
Do you know that song? No.
Wait, I gotta think about this. Is 4th of July.
Did you guys all catch that? Why I said sometimes it's okay to remove the negatives and other times it's not?
Yes, because when you add and subtract, it's drastically.
Well, in the homework assignment I did that, and it was
Divide.
just negative, when I plugged in as a negative. I just made it a negative end result.
Wait, I don't know.
Like 50.
Okay,
You
so
have to divide
when
by
we were doing the force stuff and some other things, I said just ignore the negatives and put the direction at the end. The reason why you can do that is because if you're doing multiplication or division, your negatives just tell you direction. But when you're doing addition subtraction, it's more than that. Okay? Because it's also affecting where you're going on a number line. Yes. I divide this by the 4th, I'm finished. You alright, Cheyenne?
There's nothing to look at, it's like just trials.
Oh, really?
Now there is.
You wanna look at me?
He's right.
What do we got? 8,
Thank you, Max.
4, 1, 0,
Take a triangle.
Look a hole in it.
3.995.
Well, if you're going to
Wait, Kramer, why were you allowed to play the
Why was that?
Why were you allowed to play the
I did it.
They just look
Right there.
Oh, you did try to Oh.
If your eyes are open, you're
Oh! Well, that was also interesting. That's
gross.
Zing.
I mean,
Zing.
Yes.
Zing?
No,
I
I'm
just
Wow.
realized, Sean,
I'm
that was
making it a
the
thing.
first time.
I hate it.
Okay. So, all right. Let's either prove Mr. Kramer correct or prove Mr. Kramer
Hey,
incorrect.
when you plug in with positive numbers, it just gives you negative.
Which that would.
You had a negative second, so
You're not gonna have negative
positive.
time, I mean, come on.
Okay, well, if you weren't solving for say you were solving for force.
It'd just be the opposite side.
Maybe like,
Yes, but opposite sign tells you opposite direction. That's important.
I
And
don't know
yes.
what matters.
Okay. So now that we have the time, what equation do you think we're going to be using? here?
Change x equals vx time. Change the time.
Where's
Say that again.
Change x equals vx. Change the time.
no, change in x equals vi and t.
I don't. You guys are saying I can't process that fast.
Change in x equals vx. Change the time.
No, that is your projectile equation.
Cameron, you change in x
Is the
equals
car
vi
not
t.
projectile?
What?
Change in x equals vi, change in t.
Yes.
Change in x equals
Yeah.
That's free fall equation.
What about changing say it was Jesse, I believe you.
Change in x equals
Jesse!
Jesse was right.
Where is that equation at? Oh, it's right there.
One half to be
Chapter 2.
Yes, way back. These are going to probably go way back to chapter 2 because we're doing a one-dimensional motion problem here. We're not in free fall. We're not a projectile. We're not any of that stuff.
I didn't even see that on the note card.
Yeah, I can't find that on there.
I lost my first note card of chapter 2.
Well, yeah, you need a note card that has everything. You cannot just have the chapter.
It is possible that I didn't have that.
Hopefully you
Oh.
How are you guys got to another note card?
Boring. Note card can't
Does anybody
Okay.
actually have this on their
Yeah.
board?
I do. I do.
Yes,
I promise I gave it to
it's
you.
from chapter 2 on it.
Yeah.
Way back in chapter 2.
No, it's negative.
Okay, so if you solve for change in x here, what do you get?
49.9.
I know, I got 50 on the dot.
It's right
I got
there.
50 on the.
I got 49.9.
Autumn.
Because I plug into the number, I plug in the whole.
Oh, because they
thing.
didn't.
Is it being negative?
Yeah, it's negative.
Negative. Hey, guess what? I plugged the
Okay,
negative
you
sign and I got the negative.
Instead of putting negative 50 though, it's probably best to just go 50 meters west.
Well, I wonder why we should put that instead of. It's almost like.
If it slows down west.
30.
Wait, Kramer, if it
I'm not
slows.
sure, but I plugged
Oh,
in
yeah.
that would be
I'll go
right.
right
No,
now.
I literally did it. I added
For
5.
plugging in.
Kramer, if it slows down in the west direction, isn't that positive?
No, because
It's not
So that's negative.
it's direction. How far?
That's good.
It's direction.
Oh wait, yeah.
No, I'm talking about the velocity.
If
Oh.
travel,
It slows.
cars traveling to the
No,
west.
it's not acceleration. It's velocity.
displacement.
It's slow.
So like, no, this is displacement.
No, but he's talking
about the
the
velocity.
speeds. Yeah, you're going west and then you're slowing down.
So the acceleration would be.
Negative. No, the acceleration would be positive, but you got
Why would
lost.
plug in negative numbers?
Because the velocity.
We have no acceleration we've used up here.
Oh, acceleration.
That's not-
Never mind.
I remember.
That ain't new. Any other questions here? Okay, so just remember, it's very possible you'll have to use chapter 2 equation or 2.
As a kid, we were like, and I guess like animals and
The first chapter was chapter 2. Okay?
I gotta play you.
Are we done?
Yeah.
How much time do we have?